This is the force and motion test. It's going to be 20 questions. I'm going to read each question, and you need to make sure that you circle the question's answer on your test booklet, but also bubble it in on your answer sheet. You can pause and re-listen to a question at any time, or go back to questions later on in the video. Number 1. At what point would the roller coaster car have the greatest potential energy? A, at point 3, B, at point 4, C, at point 5, or D, at point 6. All right, number 2. Which of the following examples represents the greatest amount of potential energy? F, a screen door spring fully stretched. G, water spilling over a waterfall. H, yeast growing in a petri dish. Or J, a helium balloon rising in the air. Number 3. Which of the following objects has potential energy? A, a rolling ball. B, a boulder at the edge of a cliff. C, a car going through a green light. Or D, a skydiver that is free falling from an airplane. All right, number 4. Three balls of equal size made from hard, solid plastic, rubber, and stainless steel are dropped at the same time from the roof of a building that was 5 stories tall. All 3 objects hit the sidewalk at the same time because F, they are all round objects and have the same shape. G, the downward force of gravity is the same on all 3 objects. H, all 3 objects have the same mass. Or J, all 3 objects are falling in the same direction. Number 5. Mr. Robbins is taking his baby for a walk in a stroller. The amount of force that Mr. Robbins must use to make the stroller move most likely depends on the stroller's A, direction, B, distance, C, mass, or D, velocity. All right, if you need to pause and go back at all, do that. We're going to move on to number 6. Number 6 says 4 students were asked to classify the activities of the people in the picture below as examples of either potential or kinetic energy. So here's our picture. And we have, if you can see here, there's a boy standing on a diving board. There's a girl swimming laps in the pool over here. There is somebody playing volleyball in the pool. There's somebody standing on the outside of the pool holding a volleyball. So our question says, which student correctly classified the activities of these people? So here's your options. Student 1, F, said the girl swimming laps has potential energy. The boy on the diving board has kinetic energy. The girl hitting the volleyball has potential energy. And the boy holding the volleyball has kinetic energy. G, student 2. The girl swimming laps has potential energy. The boy on the diving board has potential energy. The girl hitting the volleyball has kinetic energy. And the boy holding the volleyball has kinetic energy. H, student 3, says the girl swimming laps had kinetic energy. The boy standing on the diving board had kinetic energy. The girl hitting the volleyball had potential energy. And the boy holding the volleyball has potential energy. J, student 4, said the girl swimming laps has kinetic energy. The boy on the diving board has potential energy. The girl hitting the volleyball has kinetic energy. And the boy holding the volleyball has potential energy. Sorry, I moved ahead a little quick. Be sure to answer on your test booklet and bubble in, and then when you're ready, go ahead and move on. All right, this will be for number 7. It says, use the picture below to answer the next question. This is a student studying inclined planes using blocks of the same surface area and mass. The student sets up an investigation to measure how long it takes different materials to slide down a ramp. The results show how the ice moved down the ramp The results show the ice moved down the ramp at the least average time. And the question actually asks, why did the ice move down the ramp at the least average time? If you can see here, there is a sample of sandpaper going down the ramp, plastic, a sponge, and ice. So why did the ice go down in the least average time? A, the ice produced the least amount of friction. B, the ice is the least massive block. C, the ice produced the greatest amount of friction. Or D, the ice is the least dense block. Number 8 says, the diagram below shows a hot plate and an electrical outlet. And then it says, which energy transformation occurs when the hot plate is plugged into the outlet and the control knob is in the on position? So F, does it go from thermal energy to electrical? G, from electrical energy to thermal energy? H, from thermal energy to mechanical energy? Or J, from mechanical energy to thermal energy? All right, number 9. Students begin to measure the speed of a ball going down a ramp. The graph shows their results. So you have a graph here, and you've got distance on your y-axis, and you've got time on your x, and then our line looks like this. It comes all the way up to here. And time goes from 0 to 1, 2, 3, 4, 5 seconds. And distance goes from 0 to 4, 8, 12, 16, and 20 meters. And then the question asks us, what is the average speed of the ball? So you're going to have to calculate the speed based on the graph. You can pause to do that now if you want, and then listen to the answer options afterwards. But we have A, 4 meters per second, B, 5 meters per second, C, 14 meters per second, or D, 20 meters per second. All right, number 10. A student wanted to conduct a series of tests to identify different minerals. Which list below shows the tests the student should conduct on each of the different minerals? F, color, taste, shape, and size. G, hardness, color, luster, and streak. H, taste, hardness, color, and size. Or J, streak, size, taste, and shape. Number 11. A student who was training for a cross-country race jogged for 2.0 hours and covered a distance of 14.0 kilometers. What was the average speed of the student? So you're going to have to calculate speed. If you want to go and do your calculation now, you can. And then you can, I'll read the answer options. A, 28.0 kilometers per hour. B, 7.0 kilometers per hour. C, 12.0 kilometers per hour. Or D, this should say 0.14 kilometers per hour. All right, number 12. An egg is dropped from a balcony that is 32 feet from the ground. a timer on the ground indicated that it took 1 second for the egg to hit the ground after it was released. What was the speed of the egg when it hit the sidewalk? So you're going to have to calculate speed. And you can pause and do that now if you want. All right, your answer options say F, 32 feet per second, G, 16 feet per second, H, 1 foot per second, or J, you do not have enough information about the size of the egg to answer the question. All right, if you will move on to number 13. Looks like this. It says the graph below shows the motion of a ball rolling on a straight track. So we have a distance time graph here. Let me zoom out a little. And on distance, on our y, it goes from 0 to 2, 4, 6, 8, and 10 meters. On our time at the x, it goes from 0 to 10 to 20 to 30 to 40 to 50 seconds. And our graph goes all the way up to here. And the question said, what was the ball's average speed during the time represented in the graph? So you're going to have to calculate speed based on the graph. So if you want to pause and do your calculation, and then when you're ready, you can hit play. All right, so is it A, 0.2 meters per second, B, 0.5 meters per second, C, 5.0 meters per second, or D, 10.0 meters per second? All right, number 14. Students wanted to raise a large crate from the ground to a deck several feet above the ground. They know it'll be easier to move the crate along an inclined plane because the inclined plane will F, reduce the work needed to raise the crate. G, increase the force applied to the crate. H, increase the work done to the crate. Or J, reduce the force to raise the crate. Number 15. Which of the following inclined planes would require the least amount of force to lift a box? A, which is 5 meters tall and 10 meters long. B, which is 5 meters tall and 15 meters long. C, which is 5 meters tall and 20 meters long. Or D, they all require the same amount of force. Make sure that up to this point you've circled your answer for each one and bubbled it in on your bubble sheet. We've got 5 more to go. Number 16. A hobbyist collected data about the motion of a toy train on a straight track and then recorded the data in the graph below. So I'm going to scroll down just a little bit. So we have motion of a toy train. We've got distance on our y, and it goes from 1 to 2 to 3 to 4 to 5 to 6 meters. And then we have time on our x. It goes from 0 to 2 to 4 to 6. And then over here would be 8 seconds. It doesn't label it here because our graph ends here. Okay. So which of these accurately describes the motion of the toy train? F. The toy train speeds up while going forward, then slows down. G. The toy train slows down while going forward and then moves backward. H. The toy train moves forward at a constant speed, slows down, and then stops. Or J. The toy train moves forward at an increasing speed, stops, and then moves forward. Number 17. A student walks for 2.0 hours and travels 5.0 kilometers. What is the average speed of the student? So you're going to have to do your calculation here. You might want to pause and do that. And when you're ready, you can press play and hear the answer options. A, 2.0 kilometers per hour. B, 2.5 kilometers per hour. C, 3.0 kilometers per hour, or D, 5.0 kilometers per hour? All right, number 18. A student runs 2 times around a running path at a local park. Each lap is 3 kilometers. The student completes the first lap in 20 minutes. The student then sits on a bench and rests for 5 minutes before completing the second lap in 25 minutes. Which graph best represents the student's motion? All of these are distance time graphs. So here's graph F with one straight line. Graph G, we have a straight line here, which stops at a point and changes slightly and goes this way. Graph H, where we have a straight diagonal line, and then a flat line, and then another diagonal line. Or J, which is very similar. We've got a straight diagonal line, and then a flat line. This one's slightly longer, and then another diagonal line. Number 19. So let me make sure that was number 18. Okay, number 19. It says Kara's Saturday bike trip. That's the name of our graph. And it's a distance time graph. It goes from 0 to 5 to 10 to 15 to 20 kilometers. It goes from 1 to 2 to 3 to 4 to 5 hours. The question says, which is the fastest segment of Kara's trip? Is it between hours 1 and 2, so from basically this point to this point? From hour 2 to 3, so this point to this point? C, from hour 3 here to hour 4? Or D, from hour 4 here to hour 5? All right, last one, number 20. You're going to use this picture. It says, which of the pulley systems above requires the least amount of force to lift the mass? So are we going to pick system 1, so number 1 here, F. Number 2, system 2, G. H, system 3, or J, system 4? All right, if you will make sure that you've circled every answer on your test booklet and then bubbled them all into your answer sheet and then turn it into your teacher however they want you to do that. If you need to go back to any questions, you can rewind and do that and pause all that you need. All right, thanks.